traditional IP routing protocols. The specialized routing protocol for smart objects such as RPL, I think we discuss in the next slide. So we have that routing protocol for low power and lossy networks. Then we need to use RPL in that category. Okay. So next heading is 6 IPv6 low powered working group. These are also called as IPv6 over networks of the resource content nodes. They are mainly meant for to facilitate the IPv6 connectivity over constrained node networks. Very important thing you need to remember that this group is mainly meant for to facilitate the IPv6 connect. What are the constrained networks? So amongst them, constrained node networks, we need to facilitate the network connectivity. For that, we use this 6 low power working group. So in a particular, this group is focused on the following. Here we have given here, that is IPv6 or 4 adoption layer specifications using this IPv6 low power development technologies. We have 49446282 6775 for link layer technologies. And some examples of this group includes Bluetooth low energy, NFC. You might have heard about near field communications. I think some of the mobile uses, and I have shown you in the classes about my credit card where it uses this NFC communications, near field communications. You just pass through the particular devices, automatically it communicates with that device and transmit the amount how much you wanted to use. And for the 802.11h, for that particular we use this group. And for the DCT ultra low energy, where they're transmitting IPv6 packets. So, and the other category called WIAP, that is wireless networks for industrial automation, process automation. For that, automation itself also they use this technique, or they meant for transmitting the IPv6 packets. All these 5 examples tells you that we are transmitting IPv6 packets. Okay. And information and data models, like it uses MIB models. I think there are so many things they used. Definition of managed objects for IPv6 for low power wireless, which we discussed already. RFC 7388 is mainly used in this category. And we have to think about even optimizations that are applicable to more than one adoption layer specifications. Example, it includes RFC 7400 in that category also. And information and maintenance publications needed for the IETF specifications in this area also. I think these groups are mainly going to give all this information to the following what I have discussed with you. So they have again summarized again what exactly this group is meant for. And the next heading is 6TI-SCH. I think we use already this word TSCH, that's time slotted channel hopping. It's an add-on to the MAC layer. I think already we've discussed about physical layer, MAC layer. For the MAC layer, this TSCH, because it's going to divide the time slots. I think you might have heard about TDMA, that's time division multiple access, to communicate the various devices. It gives you a time slot called as unit of bandwidth. That means for this connectivity, how much bandwidth is used. For this connectivity, how much time is required. So in order to divide the transmission, the data with a particular time or a bandwidth, this TSCH, that is time slotted channel hopping, is used at MAC layer in the IEEE so-and-so standard called 802.15.4 with a direct inheritance from the other standards. I think it is used in other categories also. So mainly it uses, we have only left out with another 10 minutes. We'll complete whatever we can cover up. Don't worry. Okay. So what it does, I told you already, it allocates a unit of bandwidth or a time slot. That means in this time is you have to transmit, or this is the bandwidth you use. So when you want to communicate the data amongst the neighbor nodes, it also allows the programming of predictable transmissions and enables deterministic industrial type applications. That means for a particular specific applications or deterministic, where you exactly need the data to be sent in a particular time, it should be reached in 1 second, it has to reach. So when you're talking about worrying about time as a major thing to be used to get the data, then this TSCH, time slotted channel hopping, is used. It's an add-on, I repeat, it's an add-on to the MAC layer. Okay, some points related to that. So it uses some different standards, that is IEEE 80.15.4e. This group works on the architecture, information model, and minimal TSCH configuration, and it uses a role, that is routing over low power lossy networks working group. And some other points related to that, this layer provides commands to the upper network layers. So if you use RPL protocols, then it uses this, gives some commands for that particular. I mean, it's mainly used to for routing decisions, configuration, and control procedures. This TSH schedule management is used. I mean, these commands which we use for transmitting at the upper network layers. Okay, and I told you already, the time slot structure is very important. It has to give you a particular bandwidth, etc. And this affects the throughput, latency, and the power consumption. So when you are deciding the bandwidth and etc., definitely while scheduling and all, it affects. And you can see this TSH uh, top sub layer, what exactly it is, where exactly it comes under that. Okay, you can see that IEEE 804E TSCH. Because it's all theoretical, you need to go through all the points only, and you need to you need to draw the diagram. Okay, and this TSH are broken into cells. Each cell, it's a single element. It can be allocated for unidirectional or bidirectional. I told you already, because we need to allocate time or a bandwidth. So we need to divide them into cells. Cell is meant for allocating all these things. And yes, as I told you, this architecture defines, this TSCH architecture defines 4 schedule management mechanisms. This can be asked, what are the 4 schedule management mechanisms? First is static scheduling. So here, in this category, static means all the nodes in the constant network are shared or a fixed schedule. That means you should fix them here. The cells are here shared, and the nodes contained for slot access in the slotted manner. The slotted aloha is a basic protocol for sending the data using time slot boundaries when communication over a shared medium. When you are sharing the data amongst the various nodes, then you should specify the timing only. This static scheduling is used, it's simple scheduling mechanism that can be used upon initial implementation. Second schedule management mechanism is neighbor to neighbor scheduling. That means this is used to establish the correlates with the observed number of transmissions between the nodes, because you have some number of nodes amongst you, nearby you, neighbor to neighbor. When you want to schedule them, then it can be used. Cells in the schedule can be added or deleted. Means you can add any number of neighbors to you, or can be deleted when depending upon the traffic requirements or bandwidth needs. That means team can be made by your choice only. The third schedule management mechanism is that remote monitoring and scheduling management. So remotely want to monitor, allocate, deallocate, schedule, all those things can be done. That means these time slots and other resource allocation are handled by management entry that can be multiple hops away. It can be used to control or allocate with a flexibility, okay, of all the what I can call nodes when you're connecting. This third mechanism is used. Fourth is hop by hop scheduling. So node by node, you can call it as a destination node. If there are multiple hops away by requesting allocation of cells in this category, so we need to use this hop by hop scheduling. So this used by a node to trigger the scheduling mechanism is not defined at this point. Okay, this is about the fourth schedule management mechanism. In addition to the schedule management functions, this TSCH architecture also defines some 3 different forwarding models. So now we'll see one by one. That is 3 uh, TSCH forwarding models. That is track forwarding. First is called as TF. It's the simplest and fastest forwarding model. Here the track, what we use the word track in this model is a unidirectional path between a source and a destination. It's a unidirectional. It doesn't have any other directions. And this track is constructed by pairing bundles of receive cells in a schedule with a bundle of receive cells set to transmit. So a frame received within a particular cell or a cell bundle is switched to another cell or a cell bundle also. That means it's a simple and a fastest. It's unidirectional. The second one is fragment forwarding. So that means CL will divide the payload that we call as a payload size. If it is a 2048, 127, or any size it can be. So the payload can be fragmented. That means the IPv6 packets can get fragmented at this layer to handle differences between whatever we use. The payload size we use MTU Okay, maximum transmission unit. So that means MTUs can be divided, so that then we can forward them. Okay, that's the thing which it continues. Third technique is IPv6 forwarding. That's called 6F. 6, wherever we use 6 stand for IPv6. This model uses forwards traffic based on its IPv6 routing table. That means if flows of packets should be prioritized by traditional QoS, quality of service, and RED, that's called random early detection operations. That means QoS is very important on quality of services, which packets are high priored by based on the priority. Some packets can be forwarded. Okay, so see here the RED. This is used mainly. That's a random early detection is used. A common congestion avoidance mechanism. So I think you might have heard about congestion and all those things. In order to avoid all those things, then this IPv6 forwarding techniques are used. So definitely they can ask you three techniques. Apart from these management functions, it has three different forwarding models. So you should remember three forwarding models: track forwarding, fragment forwarding, and IPv6 forwarding with 6F. As this word is already in the last slide, RPL, routing over low power and lossy networks. It's another group again, just like what we discussed in the previously, what we've seen like 6 low WPAN and some group we discussed in the TSCH we discussed. Like that, here we have one more protocol called as RPL. Okay, this can be used to transmit the data again. So this group, it's used to evaluate all layer 3 IP routing protocols and determine the needs and requirements for developing routing solutions for IP smart objects. So when you use more number of, especially for smart objects, you want to route, you want to give a path for the particular, then we need to develop some new routing protocol. Okay, so by given the characteristics and requirements of the constrained networks, this new distance vector routing protocol is named as IPv6 routing protocol for low power and lossy networks. That's called RPL in short. Mainly, it's a protocol mainly for determining some of the needs and requirements for IP smart objects when they are connected in a constrained networks. Very importantly, if they have a particular requirements. Some example that given here are RPL specification 6550. Here in this network, each node acts as a router, definitely, because it's a protocol where it's going to transmit the data and becomes part of the mesh network. Routing is performed at the IP layer, okay? And each node examines every received IPv6 packet and determines the next hop destination based on the information contained in the IPv6 header, because IPv6 header contains some data. Based on that, it's going to examine the next destination address, okay? Yes, it has two models. This protocol provides two models. Storing mode, two modes. First is storing mode. All nodes contain the full routing table because we need to forward the data. We need to determine the next destination address. So first is storing mode. So all nodes contain here full routing table. Based on that, it will find out. Second is non-storing mode. So only the border routers of the RPL are going to used to connect or to send the data. Okay, so that you need to understand it. Okay, we'll stop because it's going to automatically disconnect now because it's only less than 1 minute showing you. I think another 10 or 15 seconds left out. Some of you can take just screenshot